In this video, I am going to solve this problem where I find the area of an ellipse. We are given that f of xy is equal to b square x square plus a square y square. We need to find the area of the ellipse, which is given by f of xy is equal to a square b square. Now, to solve this problem, we just take the f of xy on the left hand side and replace it by the b square x square plus a square y square. And then on the right hand side, I have a square b square. Now, what I am going to do, I am going to divide both sides of this equation by a square b square, a square b square, a square b square. Now, there will be some cancellations. B square cancel out. That gives you x square over a square. Then a square cancel out. That gives you y square over b square is equal to a square b square cancel out, that gives you 1. This equation, by the way, is the standard form of the equation of an ellipse. This standard form actually gives us a view of the ellipse, how it looks like. And this is how it looks like. If we sketch it, this is what we are going to get. Note some critical points here. So this point x-intercept is at a comma 0. This point is going to be negative a comma 0. This point is going to be 0 comma b, and this point is going to be 0 comma negative b. Now look at this equation. We have x square over a square. A is actually giving you the x-intercept, okay, here positive a comma 0, and here is going to be negative a comma 0. These are x-intercepts. And similarly, we are going to get the y-intercepts at 0 comma b, which is right here, and 0 comma negative b. Now, to find the area of this ellipse, we really don't need to find the whole area. All we need to do is find the area from here, from the first quadrant. So this area. Once we find the area in the first quadrant, what we need to do, we need to multiply it by 4 to get the area under the ellipse. This is a symmetric figure, meaning it's a mirror image about x and y axis. So what you can do, take the area in the first quadrant, and all the other areas in the three other quadrants are going to be equal. So you can just multiply it by 4 to get the total area under this ellipse. Now we are going to write down the integral for this. So we are going to have to integrate, okay, y with respect to x, y dx, but x goes from 0 to a, by the way, okay, 0 to a. So that's going to give me the first quadrant. Now, to integrate this one, we need to find the value of y, which, by the way, we can easily find just by solving for y in this equation. If we solve it, this is what we get. So we have this equation, we just solve for y basically with the standard process, and this is very straightforward. At the end, we get y is equal to this. So what we are going to do, we are going to write it down, integral 0 to a b over a square root of a square minus x square. Now we need to find this integral. Once we find that integral, we have the area in the first quadrant. Then we multiply it by 4 to get the area in the ellipse. To find this integral, we have to kind of use substitution and convert it into a trig integral, okay, and then we are going to integrate it. So what we are going to do, we are going to assume that x is equal to a sine of theta, a sine of theta. Then dx over d theta is going to be a cosine of theta, from which we can write dx is equal to a cosine of theta d theta. That's what it is. Now this integral is going to change. It is going to be integral. Now as x goes from 0 to a, by the way, is going to go from 0 to theta is going to go from 0 to pi over 2. So limits of integration is going to change. And inside I'm going to have b over a times square root of a square minus x square. So x square is going to be a square sine square of theta. All of this is under the square root times a cosine theta d theta. That's what it's going to be. Now I can just simplify it further. So let's just write it out. So let me walk you through the steps here. What I have done. Basically, after I substitute this value a sine theta for x, I get this, and then I factor out the a. Since it's under the square root, a square root is going to give me just a, and underneath the square root I'm going to have 1 minus sine square of theta, and this is as it is here. Now this a and this a is going to cancel out, and there is a b. I just pull it outside. Integral 0 to pi over 2 is going to be square root of cosine square of theta. Remember, 1 minus sine square of theta is cosine square of theta. Now this square and square root is going to cancel out. That's going to give you cosine theta, but then there is another cosine theta that gives you cosine square of theta, and this a I just pull it outside. Okay, now this cosine square of theta, I am going to write it as 2 cosine square of theta, and I divide it by 2, so I have AB over 2. These 2 and 2 cancel out, and you have this AB as expected. Now integral 0 to pi over 2, and in front of it AB over 2. 2 cosine square of theta is 1 plus cosine of 2 theta. You probably remember that cosine of 2 theta is equal to cosine square of theta minus sine square of theta. From this one I can derive this. How? Let me quickly show you. Cosine of 2 theta is equal to cosine square of theta minus 1. Sine square theta is 1 minus cosine square of theta. So if I use the negative in front, it's going to be negative 1 plus cosine square of theta. So if I simplify it, I get 2 cosine square of theta is equal to 1 plus cosine of 2 theta. That's what it is. So that's exactly what I did in going from here to here. Now I just do the integral usual. Integral of 1 d theta is theta. Integral of cosine of 2 theta is sine 2 theta over 2. And I actually need to evaluate it from 0 to pi over 2, not just pi. Okay. So there was a typo. I fixed it here. Now we are going to evaluate it. If we evaluate it, we get the following. So I just plug in pi over 2 in this, and then subtract from that this value right here when I plug in 0 for theta, and this comes out to be a nice expression, by the way. It's going to be AB over 2 times, now this is just 0, as you know, sine of 0 is 0, 2 times 0 is 0, so sine of 0 is 0, and this goes away, and this is going to be just pi over 2, because look, this cancel out, that gives you sine pi, but sine pi is 0, so that's what it is. Now this area in the first quadrant is going to be AB over 4 times pi. Now remember, we said the area under the ellipse is going to be 4 times the area in the first quadrant. So I found area in the first quadrant to be AB over 4 times pi. So the total area is going to be 4 times the area in the first quadrant, which is AB over 4 times pi, right? This 4 cancel out, that gives you AB pi. So that is going to be the area of the ellipse. Now let me summarize what I just did. Basically, I converted the given equation or given relationship into the standard form of an ellipse, and then I solved it for y and that integrated it to get the area in the first quadrant. Once I found the area in the first quadrant, I multiplied it by 4 to get the area in the area under the ellipse. Now in the integral, I did trig substitution so that my integration becomes easier, and I can come up with a nice simple expression for integral, and which we did, which is right here, and that we just evaluated from 0 to pi over 2. I hope that this discussion was helpful. Thank you very much.